Students, on Friday you guys completed this assignment. It looked a little different for you because it didn't have the graphs at the time, and if you were doing virtual, then this might have been what you saw. But anyways, Monday I passed the papers back to the students and we went over the answers. Some students did really well, some did okay, and some did not understand this at all. So this video is to help understand and explain all these problems. So this first graph, there is a car. I think it's like a remote control car. And it starts at 0. So if you were looking at a timeline, it's starting at 0. So I don't know if you can see this the best. So it's at 0, right? 0 meters. It hasn't moved yet. And as time starts going on, it's going to move forward. So at 1 second, it is at 1 meter. And then the next second, it's another meter. And the next second, it's another meter. And the next second, it's another meter. But then at 4 seconds, it stops. So from 4 to 5 to 6 to 7 to 8, the car does not move. And then time keeps going. So then at 9 seconds, it's at like 4.5. And then at 10 seconds, it's at 5. And then at 11 seconds, it's at like 5.5. And then at 12 seconds, it's at 6. And then that's all we know. Okay, so that is how the car moves. So hopefully that helps. So it went, boop, stopped, and then it moved a little slower to the end. Okay, so that helps the visual. So at what time was the car at 5 meters? So we go to 5 meters on this side of the graph, and we go over to where it hits our line because this line shows us the motion of the vehicle. And we go down, and that was at 10 seconds. Okay, at what time was the car at rest? So the car rested, we said, from 4 to 8 seconds. And so this is, you can put this as a range, 4 seconds to 8 seconds. The car ever returned to its original position? As we saw in here, it just went forward, and we don't have any more information. It never goes back to 0. So if this line would go down to 0, then we would say, yes, it did, but it did not. So, no. What was the distance the car traveled? Okay, so Tuesday, we discussed the difference between distance and displacement. And we said that distance is the total amount an object travels. So all that it traveled. And this one's pretty simple because it only travels in one direction. So we just have to look at how far, where does it end? And it ends at 6 meters. And so this car, it went 4 meters and then it stopped and then it went another 2 meters. So from 4 to 6 is 2 more meters. Okay, that's that graph. So we're going to move on, and now we have 2 girls run a race. Maybe they're in track, and it's a 50-meter race. And so, so 50-meter race, and it says, at what distance was Jen at 5 seconds? And so now we have to go to the 5 seconds and go up to Jen's line, and that is at 40 meters. At what time did Anne reach 20 meters? So Anne's line is red, so we go to Anne, and we go to 20 meters, and we go over to Anne's line, and that's about 3 seconds. How long did it take Jen to run 50 meters? So 50 meters, and you go over to Jen, and that's at 6 seconds. How long did it take Anne to run 50 meters? So Anne, go to 50 meters, and we go over, and it took Anne 8 seconds. So that's the next one. Okay. We have 2 more here. The graph shows the motion of a runner. What was the initial starting position? So initial means starting or beginning. And so it started at 0 meters. Position means like location. So its location is 0 meters. Hasn't moved yet. What was its final position? So the very last point that we have is at 800 meters. What was the total distance traveled? Again, it only went in a straight line, so it's pretty simple to see that this runner ran 800 meters, and so that is their distance. How long did the runner run? It would just be, so this line starts here and it ends up here, and so what time was that? 4, and the unit is minutes. I had lots of students just write 4 seconds because all these other ones were in seconds. Another side note, when you make a motion graph, you always put time and your unit at the bottom, and then distance and the unit on the side. That's very important to do. Okay, this last one says to describe the motion of the object. When you describe the motion of an object, you should use as much detail as possible given your graph. And so definitely include your numbers and your units in your description. So the object starts at 0, and this is very detailed. So you can say the object starts at 0 meters, moves. So because it's a straight line, it's going to move in a continuous speed. We haven't talked about this yet, but it's moving in a continuous speed. And so you could say that it moved 15 meters in 10 seconds. Then the object stops or rests for, and then from 10 to 15, that's 5, and then 15 to 20, that's another 5. So it rested for 10 seconds. And that's what we know based on this graph. I'm hoping that this description and answer key will help you. If you have any questions about interpreting graphs, we have a lot more after break. We're going to learn a lot more about how to actually calculate speed from the graphs. And so it's really important that you understand how to interpret and analyze and get this information I'm asking you to get now. If you have any questions, let me know.